Hello, some of you asked for me to record how to set up a spreadsheet for lab number 2 with the metric system and analysis of error with respect to weighing out 50 milliliters of water from a variety of pieces of glassware. In this tutorial, I'm going to show you how to do this calculation for one of your pieces of glassware, but then you would have to do this for all the other pieces of glassware that you used in lab. For example, you would go ahead and apply this to the pipette and the burette and every other piece of glassware that you did this measurement for. I'm going to actually show you some example data for a 600 milliliter beaker and what one of our students actually did collect. So this is actual data that another student had collected. At the very top of every spreadsheet that I ask you to set up, please put your entire name. So here I'm putting my name at the top of the spreadsheet, and I can resize here by dragging this cell to the right so that I don't cut off part of my name. Below that, put your lab partner's name, or if there were several people, list each person that helped you in your group. So here I'm going to have an imaginary lab partner. Let's say I work with Sally student. And then below that, I would like you to add your date. So I'm going to put today's date when I'm making the recording. So that's going to be February 1st, 2013. And then I'm going to list what work was being done on this spreadsheet. So since there was only one spreadsheet required for this lab, I'm going to say that it was lab number 2. We're working on the post-lab material. Now you may actually prepare several spreadsheets if you do a separate one for each piece of glassware, or you may decide to include all of your calculations for all the pieces of glassware in a single spreadsheet. The example I'm looking at here would include thinking about what the actual value is you're trying to measure, and you realize that you're trying to measure out 50 milliliters of water, and if you actually hit your target with respect to measuring 50 milliliters of water, when you weigh the mass, your true mass or your actual mass would be 50 grams, right? Because the density of water is going to be, to two significant figures, 1.0 grams per milliliter, or 1.0 grams per centimeter cubed would have the same meaning. So here I'm going to reference a true mass in grams, and I'm going to put the true as a subscript. So under my font menu, I'm selecting subscript here. Okay. And then next to that, I'm going to list for reference the 50 grams for my true value. Down below, I'm going to start setting up a table to look at all of the data I'm collecting. So I'm going to put some headings on my table so it's very clear for somebody grading your Excel spreadsheet as to what you've recorded in every location. So first of all, I'm going to list the container used to measure the volume of water here. And if I want to wrap that text, I can right-click on that cell with my mouse, go down the menu to Format Cells, and I want to, at the top here, to click on the Alignment tab, and I'm going to click on Wrap Text. Now that text will wrap down for me when I'm looking at it. Okay. Below that, I'm going to state which piece of glassware I'm working with. I'm working with a 600 milliliter beaker. I'm going to note that I'm working with it 3 times, so I'm going to use my shortcut on my keyboard, Control-C to copy, or you could use the copy off the clipboard menu up here at the top if you wanted to. I'm going to go ahead and paste that twice more, so I left-click with my mouse, drag down 2 cells, and then I'm going to either paste off of my clipboard menu, or I use the shortcut on the keyboard, which is Control-V to paste. Control-P is print. That's why that's not the correct shortcut, so Control-V is the one for paste. Then I'm going to notice that I want to record the initial weight of the 100 milliliter beaker. Grams. And after that, I'd like to also write down the final weight of the 100 milliliter beaker plus the water I put in it, right? In grams again. Okay, and then my next column will be the weight of water in grams, which is merely the difference of the previous two masses. So I'll take the mass of the beaker plus water, then I'm weighing by difference when I do this. I'm subtracting the mass of the empty beaker from the mass of the beaker with its contents, the water. That difference will be the weight of the water alone. We'll be doing that quite a bit in the lab, so become comfortable with determining masses by difference that way. My last column here, I'm going to have example cell calculations. Now, right now, my text is a little cramped, so I'm going to go up to the font menu again on those cells and say, let's, under the alignment tab again at the top, let's wrap the text. And I may resize it slightly. Let me see. I want this one to be a little larger. And my weight of water, I'm going to make that a little bit larger here. My example calculations, I'll make larger. And then just to kind of make sure everything's nice and neat, what I'm going to do for my cells here, I'm selecting a few extra for calculations we're going to be performing. I'm going to right-click on the mouse and format those cells. And I'm going to tell it under the under the alignment tab here that I want to center it. I could have also gone to the top here under the alignment. Under the Home tab, there's an alignment menu. I could have hit center there as well, which is probably would have been the fastest way to do that in this case, so I didn't navigate menus. Now, with respect to my headings, I'm going to make those bold so they pop a little bit, so I know those are headings for my data. Then I'm going to type in the data for the initial weight of my 100 milliliter beaker. So my first weighing was 50.668 grams. I make sure I record all the digits from my scale so I don't lose any significant figures from that measurement. I'm also going to record 50.617 grams and 50.751 grams. So there's my three weights for the empty beaker measurements. Now the beaker measurements with water were 98.678 grams, 102.644 grams, and 95.852 grams. Okay, now next I want to calculate the difference between those two. So what I'm going to type into the weight of water cell is a calculation. So I'm going to hit the equal sign on my keyboard and then reference the cells I would like to take the difference of. So I'm taking the beaker weight plus the water, which is in cell C7 on my spreadsheet, and I'm going to hit the negative sign on my keyboard indicating that I want to subtract a number, which I could either type in a number or I could reference another cell. I'm actually going to reference the cell here in cell B7, so that's going to subtract the weight of the empty beaker from the beaker I had just before I weighed the water. I can hit enter now and that calculation will be performed for me. You notice that as we perform that calculation though, we actually lost a significant figure. Our spreadsheet won't notice if we're losing significant figures, so I would want to right click on my cells here where I'm going to be performing those calculations. With my mouse, I right-click and then go down to the Format Cells here on my menu, and I want to go to the Number tab here at the top left. Under the Number tab, under Number, I'm going to tell it I want 3 decimal places so I keep track of the correct number of significant figures. I often see students forget to actually correct their significant figures on their spreadsheets, and sometimes they'll lose some points for doing that, so try to remember to do so. I can go ahead with this calculation in this cell, and I want to show my instructor what I did there. It is a fairly simple calculation, so this one would be one that I probably wouldn't penalize you for if you hadn't shown me a one-step calculation like a subtraction here. I can easily have checked that off your spreadsheet, but I'm going to show you the best possible way you could show this, especially if it was a multi-step calculation. We can go up here to the formula bar, and I can highlight the equation that I'm performing, and I can hit Control Copy, or copy it off my clipboard. And then before I click on any other cell, I want to hit enter. Otherwise, I will try to reference another cell in my formula bar and will change my calculation. So I hit enter first. Then I'll go over to my example calculation column and paste. I can either use paste up here in the clipboard or my shortcut Control V on my keyboard. Now right now we're merely performing the same calculation, and I actually would like to display the equation that I'm performing. So if I go up to the formula bar again, I can put an apostrophe in before the example cell calculation, and now that apostrophe says please print this in the cell as text rather than as a calculation. So I can see the text that I was using here. And if I wanted to align that to the left, I can go up to my alignment tab window up here under the home tab of the alignment section and hit to the left tab for alignment, align to the left. I can also copy the calculation from the weight of the water calculation by hitting Control C. And then you notice I have a flashing border indicating that I'm referencing that cell right now. And then I can left click on cell D8 and drag my mouse down, the number of cells I would like to perform the same calculation, down to D9. And at this point I can hit Control V, and we'll notice that we paste in our calculations, and we can always click on a cell and note that I have incremented down the spreadsheet to the correct cells I wanted to reference. That's always good to double check in case you didn't increment the way you thought you would when you set up your spreadsheet. Now remember from our last tutorial, if you wanted to freeze a cell reference when you're pasting, you need to put a $sign before the cell letter and before the cell number. If you put it before the letter with your $sign, that indicates please do not increment the column. And if you put it before the number, it indicates please do not increment the row. And it would keep referencing an individual cell. We'll actually be doing that with our true value here in a few moments. Okay, so we have all of our calculations. The next thing we want to do is calculate a mean value. Okay. I'm going to leave myself a little space. I'm going to calculate the mean in grams, and then I'd like to calculate my percent error, will be my next error calculation, and then my standard deviation calculation would be after that with respect to the grams that I'm weighing out, and then my percent relative standard deviation would be the next calculation. Now I'd like you to note that I'm trying to always label here the units that I'm using with respect to my numbers. If I don't always want to have it in the cell with the number, or I can't perform a calculation on it, but I need to show it somewhere. So I show it in my headings for each of my columns. What units am I working with? This is a good practice. So anybody else looking at your spreadsheet would know that you're working in grams and not pounds or not milligrams or some other value. So where it's quite clear what you're reporting. Okay, so I'm going to calculate my mean here, and there's a built-in function on that cell which will do this for you very easily. You could do it by hand simply enough for 3 data points, but let's say you had several hundred. You actually could do it much more quickly with the built-in function. So if you don't know the name of the function, you can go up to the question mark here at the top for a help menu and search for average or a mean. Luckily, you could probably guess what the function name is here. It's just average, so I start to type in average, and this is the correct function. If you're not sure which of the average functions you should be using, please go to the help menu and make sure it's performing the calculation that you think it should be. So I go ahead and double-click on the function I would like to use, and right now it's prompting me for a set of numbers, and I can easily hit my left mouse button on the numbers I would like to reference. You notice now I'm referencing cell D7, and if I keep holding my left mouse button, I can drag my mouse down to a total of 3 cells, and now I'm referencing cell D7 down to D9. That's all 3 cells that have a flashing border around them currently. Now I can either close my parentheses on my keyboard, or if you hit enter, it will automatically append with a close parentheses to your calculation. So now we have a mean that we've calculated. The next thing I want to calculate is a percent error. Now remember, our percent error will actually help us with respect to seeing your accuracy, because your percent error will reference your true value. So for my percent error, I'm going to type in equal, because I'm doing another calculation, and I'm going to do this one by hand. I'm not going to use a built-in function. I'm going to say that's equal to my measured values, and where I have multiple measured values, I'm going to use my mean value here. So I'm going to go ahead and take the mean that I have, and I'm going to subtract my true value. So my true value will be the mass true, which would be 50 grams if I really had 50 milliliters of water that had been measured out, which likely were a little different than that, so we're going to have a little bit of percent error occurring because our accuracy isn't absolutely perfect. So I'm going to go ahead and reference that cell. Now, if I wanted to use this calculation for another set of data, I want to be very careful that I don't increment from the true value cell. So I'm going to tell it I want to freeze that cell, that column, and that row. So I'm putting a $ from my keyboard in front of the column, E, and in front of the row 2, and that way if I copy this calculation into any other part of my spreadsheet, I will always reference that identical true value cell. Okay, so we're calculating that my percent error for this data. Well, we're not quite done with the calculation. Let's go back into it. Now that difference there of my measured value minus my true value, remember for the next part of the calculation we divide by the true value, or what was in our equation was the actual value. So I go ahead and reference that cell again. If I were to ever use this again, I don't want it to increment, so I put my $ in front of my row and my column to make sure that I wouldn't increment. Now, if I'm calculating a percent error, I also need to multiply it by 100 with respect to this value. This gives me a percent error of negative 3.241%. Now the negative is actually telling us that with respect to accuracy, on average our measurements are reading below the true value, which makes sense. If you look back up here at your mean, you'll see that your mean value is a little bit below 50. So we actually see with respect to percent error that indeed it would be a negative error with respect to accuracy. If our value had been greater than 50, you would have seen a positive percent error. Remember, that's relating to accuracy because we're comparing to the true value here. So the accuracy for this student was not unreasonable, though we'd want to compare it to our other glassware to see which one gave us the best accuracy. Now with respect to my standard deviation calculation, that's built in, but remember I've asked you to know how to use your calculator in the testing center to calculate a standard deviation, and make sure that you are performing the same calculation that I taught you in lab, where we used each individual measured value at sub I minus the mean or the average, which is at sub m. We take that average from every measured value, and then we square those and sum them up. That was what the capital Greek letter sigma represented, was the summation of each of those terms. And then we subtract by n minus 1, which was our n is our number of measured values. In this case, that would be 3. Minus 1 would be 2. Divide that into our summation, and then take the square root. That would give me a standard deviation. You need to be able to do that by hand on the testing center, but on the spreadsheet, since on the previous tutorial I already showed you how to do it the long way, this time we're going to use the shortcut on the spreadsheet in the built-in function. So the built-in function we used last time was standard deviation, or standard deviation A. We'll perform the calculation with respect to what we want it to do, and I can merely left-click my data set and drag my with my left mouse button depressed, drag my mouse down 3 cells, and we can see we're selecting all 3 cells because of the flashing border. And then I can hit enter, and that will close my parentheses, and I've calculated a standard deviation. So we did that fairly quickly. You'll notice that this has an obscene number of decimal places, and so that's not really a reasonable number of significant figures. So I would want to right-click on this and go ahead and show fewer decimal places. I'm going to show 4. So let's go into the number, and we'll show 4 total significant figures. We're going to show that many decimal places. So that's my standard deviation. To calculate my percent relative standard deviation, that's going to be equal to my standard deviation, so I'm going to reference that cell, divided by my mean, which was cell D12, times 100. So it's just standard deviation. My lowercase s, if you'll recall, is often used for standard deviation, so you may see that in some cases. And then divide by the mean times 100, and you'll notice at no point during a standard deviation calculation do we reference the true value. So if I didn't know a true value in the lab, I could calculate standard deviation just for how my data is scattered with respect to the mean, because we keep in our calculation referencing the mean value. So this is a indicator of precision. So the smaller your percent relative standard deviation is, the better your precision was with this piece of glassware. Okay, so if we go ahead and calculate that here, we see we have about 7.19% with respect to percent relative standard deviation. So the precision was reasonable but not stellar, but for a 600 milliliter beaker, we're not that surprised if we have a large set of errors. In fact, I'm a little surprised that this student set of data had such a small percent error, but the percent relative standard deviation is reasonable. Sometimes I've seen it even larger than this. The number of significant figures, again, is outrageous with respect to the spreadsheet. It didn't keep track of them, so I'm going to right-click and format my cells and reduce my number of significant figures down again to show fewer. So it's a much more reasonable number of significant figures that we're keeping track of with respect to it. Now I still need to show my example cell calculations, so I'm going to go ahead and grab those from each of these error calculations and the average that I performed. So I'm going to go up to the formula bar, copy that, hit Control C, or use the clipboard to copy it. Then before I click on anything else, I always put Enter, and then I go to the cell where I want to paste it, Control V, or I can paste from the clipboard here at the top. And I put an apostrophe before the formula, and I'm going to repeat this for every one of my formulas. So I'm selecting each one, copying it, hit Enter before I do anything else, go ahead and paste it. I need to put the apostrophe on the formula bar each time to make sure I show test rather than perform the calculation. Oops. So I'm going to do that each time. Now if I forget to hit Enter after I copy and then I click on another cell, you notice it erased our calculation and now it's trying to reference the new cell for a new cell calculation. If that accidentally happens to you, just go ahead and undo the last thing you performed under the undo arrow at the top. I'm going to go ahead and copy, hit Enter, then paste, and my apostrophe. So I'm just repeating this, so feel free to fast forward if you don't want to watch this portion of the tutorial. But I would want to see this. I need to see at least the first time. Now, if you've proven to me on a spreadsheet for the 600 milliliter beaker that you can do these calculations and you've entered them here under the example calculation portion, I wouldn't necessarily expect that you do it on all the other pieces of glassware. You don't have to show me the example calculations. I'm assuming if you knew how to do them here, you knew how to do them on the rest of the spreadsheet where you're repeating the same calculation. Just make sure you've shown it to me at least the first time. You notice I did that even for the example calculation where I was subtracting the mass of the empty beaker. I only showed it the first time, and then I assumed, oh, of course that student understands how to do it for all the other calculations. So give me one example and I'll be quite happy. Now I'm going to go ahead and just do a little bit of spring cleaning and formatting of our table to make it a little nicer. So I'm going to go ahead and label my table by formatting cells. I'm going to go ahead and put borders on it. So you'll notice under the Format Cells there's a border tab here. It's the third tab from the right. So I'm going to hit that border tab, and I can choose whatever border I would like. If I go with the default, I can outline and then put inside and show those. If I want to show that I'm doing something underneath the weight of the water, I could be a little fancier and format my cells and say that I want to have a double border there just at the bottom line. You'll notice now, since I click here under the border selection, that I'm only showing the bottom of that cell with a double line. That's nice for emphasizing when you're doing addition or subtraction for a group of data. This is just some ways to spruce it up. I could also color code these to show they're the ones I'm referencing with respect to my calculations. So I've highlighted in yellow. Just under the Home tab, under the font option, I can change the fill color of my cells. Under the calculations, let's say that I wanted to stress that I'm good to go to hand this in, I'm going to use green there. Now you notice, especially once I do a fill, if I don't have my borders present, it's a little bit hard to read those calculations from one line to the next. It's just a little more pleasant for the eye if you go ahead and edit by right-clicking and then left-clicking on Format Cells. You can click your outline of these cells. And now we have a nice spreadsheet. You didn't necessarily have to add the colors, but it was a nice touch, I thought. We can also change our alignment if we'd like to present it however we would like. So just a few aesthetics and qualities we can add there. If you have any questions, please email me. I hope this tutorial helps. Realize this is only the first part of the spreadsheet I expect you to prepare for lab. You will need to do the same type of calculation for each piece of glassware. But you can see how simple it would be to take this set of calculations and copy it and then add it to a new section and then update the names of the glassware, update the masses you're working with, and you actually will end up updating all of your error calculations. For example, if I ended up putting in a pipette here, and I would do that for all three pieces of glassware, of course, not just one. We could go ahead and have a different mass, and if I have a different mass here, and a different mass here, you'll notice we're automatically updating the mean, the percent error, the standard deviation, the percent relative standard deviation. So you see how much time that actually saves you compared to doing it by hand. So you could go ahead and update each of these for each piece of glassware, but it won't take you very long after you prepare the very first part of your spreadsheet. You'll find it goes quite rapidly. I hope this tutorial helped. Please send me a little message by email or talk to me and let me know if these tutorials are being useful to you so I know if I should keep recording them this semester. Thank you very much. Have a great day, everybody.